What's up, everybody? In this video, we are going to toggle two LEDs using variables. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we edited in the previous video. Hover over the circuit and click on the gear in the top right-hand corner. Select Duplicate. Click the name of our circuit in the top left corner and change the name to Toggle an LED. Fill out the information in the header of our code. Update the program name and description. The program name is Toggle an LED, and the description is a sketch where we will toggle two LEDs using variables. Close the code panel and add two LEDs to your breadboard. I'm going to use one red LED and one blue LED. You can pick whatever colors you like. Remember that the cathode from each LED connects to the ground. On the LEDs from your kit, the cathode is the side with the flat edge. We will need a resistor for each LED. Select a resistor, rotate it, and add it to your breadboard. Change the value to 220 ohms. Repeat this for both LEDs. Last, we will connect each LED to a different pin on the Arduino. I'm going to connect the blue LED to pin 3 and the red LED to pin 2. Great, we've built our circuit. Now we are going to explore variables and how they can be useful when we code. Click on the Code tab and ensure the text drop-down is selected. Go to the end of your Declare Variables and Load Libraries comment and hit Enter. Type int red pin equals 2, semicolon. Int red pin equals 2, semicolon is a variable declaration. In programming, a variable is a value that can change. Before you use a variable in programming, you need to declare it. When you declare a variable, you are telling the program the variable exists and optionally assigning an initial value. When we are programming the Arduino, we also need to tell the program what type of data will be held in the variable. In this case, int refers to integer or a whole number. Red pin is the name of the variable, and the initial value is 2. There are different types of variables that we will explore as we progress through the course. It is good practice to declare your variables at the start of your program. As programs become more complex, they can have many variables. In the setup function of our code, we need to tell the Arduino that our LEDs will be an output. Underneath the serial statements, add pin mode, open bracket, red pin, comma, output, close bracket, semicolon, and pin mode, open bracket, 3, comma, output, close bracket, semicolon. You will notice in the output statement for the red LED, we are using a variable, but for the blue LED, we are using the pin number. I'm doing this so I can illustrate the usefulness and how to work with variables. Next, in our loop function, we will set the states of the LEDs to turn them on and off. Add digital write, open bracket, red pin, comma, high, semicolon, and digital write, open bracket, 3, comma, low, close bracket, semicolon. Next, add delay, open bracket, 500, close bracket, semicolon. Copy and paste the digital write for both the red and blue LEDs and swap the values. Click on Start Simulation, and you should see the LEDs alternating on and off. If we compare the code in our loop function, you will see that the pin number for the blue LED is hard-coded in the loop. Many times, when you are working with an Arduino, you may need to change where a component is connected. For example, if we change the pin of the red LED to 6, we can update our entire code by changing one line. Let's try it out. Single-click on the wire that connects the red LED to the Arduino. Next, click and drag the endpoint of the wire from pin 2 to pin 6. Next, change the variable declaration to int red pin equals 6, semicolon. Click Start Simulation, and you will see that the program still works. If we wanted to change the pin for the blue LED, we would need to update every line that references pin 3. Right now, we only have 3 lines of code, but if we had a very long program with a lot of references to the pin, using a variable will make it much easier. We're going to add more variables. In your variable declaration section of code, add the following: int blue pin equals 3, semicolon, and int delay speed equals 500, semicolon. We've added 2 new variables. Int blue pin equals 3 is the pin number for the blue LED. Update all the lines of code in your program and replace the number 3 with the variable name blue pin. Int delay speed is going to control the length of time that the delay function occurs. Replace the value of 500 in all delay functions with the variable delay speed. Click Start Simulation and test your circuit. You should see the LEDs alternating on and off. Stop the simulation and try changing the value of delay speed. If you make it a smaller number, like 150, the LEDs will alternate faster. A larger number will slow down the alternating of the LEDs. Awesome! We can easily make changes to how our program functions by changing one line of code. Great! We're going to introduce one more variable to our program. Below your variable declarations, add the code bool LED state equals true, semicolon. A bool is a true or false value. We are going to use one variable to set the state of all LEDs. Next, replace all high and low values with the variable LED state. Click Start Simulation. Since the LED state variable is set to true, all of the LEDs turn on. If we change the state to false, the LEDs would turn off. Stop the simulation. Update your code so there is only one digital write for each LED and one delay. Add the following code: LED state equals exclamation mark LED state semicolon. The exclamation mark is known as the negation operator and reverses the meaning of a value, so true becomes false. Click Start Simulation and you should see both LEDs blinking together. If you change LED state to exclamation mark LED state in one of the digital write statements, it will cause the LEDs to alternate. To recap, at the end of this video, you should understand variables and how they can be used in programming.